Okay, question multiple choice 17. The length time that Sammy walks to school is normally assumed a mean of 18.4, standard deviation I don't know. So this is Sammy, and walking to school, mean of 18.4. On a sample of 30, we can be 99% certain that the sample mean will differ by less than 0.8 minutes. 99% sure that the sample mean is somewhere between here and here, and that's 0.99, and that's going to be 0.8 minutes. So up to 19.2 and down to 17.6. But I don't know what the standard deviation is. So I'm going to need to use my z-score. If I do a z-score to get our centre 0.99, where the mean is 0 and the standard deviation is 1. So in interactive distribution inverse normal CDF, I want a centre at 0.99. That gives me that value. So that value there is 2.5758. So 2.5758 should equal 19.2, because 2.57 corresponds to 19.2, minus 18.4 over I don't know divided by the square root of 30, since this sample mean came from a sample of 30. So on the calculator, so I've entered all that there. I've taken all of the decimal places, and I have done the square root of 30. And if I solve for x, I've used x for the standard deviation. It gives me an x value of 1.70. I might go 1.7. So that's question number 17. In question 18, we have a rule for velocity in terms of i's and j's, and we have an initial position 2j. The particle's position when the magnitude of the acceleration is 2. So a of t will be the derivative of this, which will equal 6t to the half. So that should be 3t to the negative a half in the I, minus, that's going to be t plus 1 to the negative 1. So it's going to be plus 1 on t plus 1 squared in the j. And we want the acceleration to equal that. So 2 equals the square root of 3t to the negative a half squared plus 1 on t plus 1 squared. Put that in the calculator to find out what that is. 2 equals, okay, so I've got 2 equals that expression, which is that. Solve, I'll ignore the 2 negative answers and take 2.2550. So t equals 2.2550. So that's the time that the acceleration is equal to 2. I've got to find its position. So I need to integrate this expression here, and x of t is going to equal 6t to the half will be 6t to the 3 on 2 on 3 on 2 in the I. Integrate minus log base e of t plus 1 in the j plus some constant c. And I know that the initial position is 2 in the j. 2 in the j. So 2 in the j equals 0 in the I, minus log base e of 0 in the j plus c, so c equals 2 in the j, which gives me expression for x of t, and it's going to be 4t to the 3 on 2 in the I plus 2 minus log base e of t plus 1 in the j, given x equals 2.255, so that what I might do is I will copy that, maybe some more of it, So my first one is 4x to the power of 1.5. Math 3 given x equals that value, and that gives me an x coordinate of 13.545, 13.55 or 13.55. So we've got rid of those ones, but it could be any of A, B and C, A, B and E. And the y coordinate is 2 minus logarithm of x plus 1 given x equals all of this, and that gives me an answer of 0.82 positive. So I'm looking at A. A lot of work for 1 mark.